As you might have anticipated from the quiz, before we delve into brain cells, connections, learning theories, and strategies, it is really important to talk about memory. Memory can be defined as the process of taking in information from the outside world, storing it in the brain, and later recalling that information to complete a task, solve a problem, make a decision, or some other response. There are 3 basic stages in memory processing. The first stage is encoding, where your brain perceives what is happening around you, and it is very selective. You've probably heard of selective hearing, but did you know that our brains are selective in taking in information all the time? Think of sitting in a coffee shop. Some people can sit in a busy coffee shop and work, tuning out all of the activity around them, choosing to filter out distractions. Your brain is like that. It would be impossible to process and react to all of the information and activity that you are bombarded with all the time. So your brain filters out what it perceives as, irrelevant. Some factors that facilitate encoding, that of course influence what we perceive as relevant, include our own emotional content, novelty, and of course, what we choose to pay attention to. This means that the things that stick in our memories are things that we have an emotional connection to, or things that are unique or surprising. The next stage of memory processing is storage, in which, after an event is encoded in the brain, that information may be consolidated. This happens via actual physical and chemical changes in the brain. These changes are called memory traces. After your brain creates these memory traces, these traces have to be strengthened through retrieval. Retrieval, of course, is the act of remembering something, bringing the information from that memory trace back to the front of your mind. So we have to be able to access the information stored in our brains in order to actually respond to the world around us. It's important to note that every time your brain retrieves information, the memory trace that was created during the storage process becomes vulnerable and susceptible to further changes. Therefore, the process of retrieval can either make the memory trace stronger or weaker. When we consider how this impacts our learners, we need to ensure that the retrieval process strengthens our learners' memories of information they've stored. For example, if we ask learners to recall information, something they've been taught, and they recall that information incorrectly, it is vital that they receive corrective feedback immediately. Otherwise, they've strengthened a memory trace with incorrect information. Let's talk for a moment about 2 different types of memory: long-term memory and working memory. When you think of long-term memory, it might be useful to visualize a warehouse. And if you're an Indiana Jones fan, imagine Hangar 51, where the Ark of the Covenant is secured at the end of the Raiders of the Lost Ark. Anyway, long-term memory is unlimited information storage for a lifetime. Working memory, which sits right here in the prefrontal cortex and functions as our processing unit, has a limited capacity. If long-term memory is a vast warehouse, working memory is a shoebox. In fact, as mentioned in your quiz, for the average adult, working memory can only hold about 7 items at a time. Attempting to hold too much in working memory can result in cognitive overload, which, as instructional designers, we want to avoid at all costs. Developed by John Sweller in the 1980s out of a study on problem solving, cognitive load theory incorporates 2 primary assumptions that impact our work in designing learning experiences. 1, working memory has limited capacity, and 2, our ability to use information already stored in memory is unlimited. Neuroscientists know, and your own personal experience probably confirms, that there's only so much our brains can process at one time. According to cognitive load theory, if your brain is asked to process too much information at once, you will experience cognitive overload. You can probably recall a time when you've experienced cognitive overload. When you were presented with too much information or stimuli, you might have felt overwhelmed, frustrated, or even frozen. When learners experience cognitive overload, they may feel so overwhelmed that they shut down, avoid taking action, and hesitate or even refuse to return to the content. When we design learning experiences for adults, we want to be mindful of reducing cognitive load, eliminating distractions, presenting only that information that is relevant to the task at hand, and organizing content into manageable chunks to help them avoid feeling overwhelmed or stuck. Obviously, our ultimate goal is to help learners consolidate content into long-term memory and strengthen their ability to retrieve it through practice. In the next lesson, you'll learn some strategies to help you do just that.